Hello Year 9s. We're going to have a look at functions today and a little bit of function notation. Now, like some of the other topics we've looked at recently, this is something you've looked at before. And what we're basically doing here is we're thinking just about a different type of notation for something that we already know how to use. So if you've got something like y equals 2x plus 3, we can think of that as being 2 times something plus 3, and that will give us our y value. So we know that if x equals 5, y will equal 2 times 5. Remember, we quite often write that in a bracket, don't we, in our maths, plus 3. So in this case, y equals 10 plus 3, which is 13. So we know about that notation. That's what we call just a normal equation. Now this can be written in another way. This can be written as a mapping. And some of the questions in the book are about mappings. I'm not going to set you any of them, but we'll just have a look at it as an example for this one. So if we had the mapping that takes a set of numbers from one place to another place, and this set of numbers is going through a mapping of 2x plus 3, what we can basically say is that the number 5 would be multiplied by 2 and have 3 added to it, so we'd end up at 13. The number 1 would be 2 times 1 plus 3, that would be a 5, and if we had 10, say, 10 would be 2 times 10 plus 3, which would take us to 23. That's a mapping notation, yeah? These numbers here end up at those numbers there when they go through this timesing by 2 plus 3. This can also have another name, and you know what I'm going to say it is. It actually means it's a function. So function notation basically looks like this. It says f of x instead of a y equals 2x plus 3. Sometimes you'll see it written as f of x with an arrow going to 2x plus 3. And that notation is basically referring back to this idea of a mapping. Now, instead of saying here where x equals 5, what you can do with this notation, which is really nice, is you can take that value of 5 and put it into a bracket there. And you can say f of 5 means that wherever there's an x in your function, you're going to replace it with a 5. So instead of f of x, you've got f of 5. So instead of 2x, you've got 2 times 5, and then you've got the plus 3. And we know that that equals 13 because we looked at it up here. Similarly, just looking at the examples we did here, f of 1 would equal 2 times 1 plus 3, which would give us 5. And finally, f of 10 would give us 2 times 10 plus 3, which is 23. So this is an equation, this is a mapping, and this one here is a function. Okay, just different ways of expressing this idea of multiplying a number by 2 and adding 3 in this case. Okay, I'm going to do a few examples now that I'd like you to write down. So get your books out, your pens out, and I want you to write these ones down. You don't need to write this, but the ones I'm about to do, I want you to write down. So, I'm going to start off, I think, with let's do, so example 1, let's do example 1. I'm going to say y equals 6x minus 12. And my first question is going to be, how do we write that in function notation? Well, in function notation, you would write it as f of x equals 6x minus 12. And then I'm going to say to you, well then, what would f of 10 be? Well, we know from our notation that we talked about earlier that this just basically means that we put a 10 in the place of an x into our function. So we're going to do 6 times 10 minus 12. 6 tens are 60, minus 12, that's going to be 48. Let's try another one then. Let's do f of 4. F of 4, 6 times, instead of an x, we're going to use a 4, minus 12. 24 minus 12, that's going to give us 12. Be careful, sometimes you're going to get a negative number. What about if we do f of 1? F of 1 here will give me 6 times 1 minus 12. 6 minus 12 will give me minus 6. Final example. What about if we have a negative number to put into our function? F of minus 2. You treat it in exactly the same way, but you have to remember your rules of negative numbers. We've got 6 multiplied by minus 2, minus 12. 6 times minus 2 gives us minus 12, minus another 12 is minus 24. Okay, so we followed that one through. Let's look at a slightly harder example. So if you haven't quite written all of these ones down yet, just take a moment to write them down now. Whilst you pause it, I'll just do a bit of rubbing out. Okay, example 2 this time. This time, my example is going to be y equals 1 over 2x plus 4. That's an equation. We're going to write it in function format. F of x is 1 over 2x plus 4. The process is going to be exactly the same here. If we want our x to equal 5, say, we would use f of 5. F of 5 would be 1 over 2 times 5, where there was an x, you put a 5 this time, plus 4. That equals 1 over 10 plus 4, which is 1 over 14. Let's use a negative number just to make our lives a bit more difficult. So let's do x equaling minus 3. So we are going to end up with 1 over 2 times our x value, 2 times minus 3, plus a 4. That's going to give us 1 over 2 times minus 3 is minus 6, plus 4, which is 1 over minus 2. Minus 6 plus 4 is minus 2. And that means that the whole thing is negative. We just write it as a minus 2 there. I'm just going to put one more on this side. I don't want to go off my board. What would happen if we did f of minus 2? This is an interesting thought. F of minus 2. So f of minus 2 would give us 1 over 2 times minus 2 plus 4. That would give us 1 over minus 4 plus 4. Well, minus 4 plus 4 is 0. That is not possible as a solution. So you would actually say there is no solution here. So if you've got something that gave you a 0 on the bottom of a fraction, you can't divide by 0. Try it on your calculators and you'll get an error message. So be careful, look out for these ones. I think there might be one in the exercise hidden somewhere. There will be no solution if you end up with a 0 on the bottom of a fraction. Right, just going to do one more example with a slightly harder function. So if you need to copy this down, you just copy it down now. Pause for a second, and then I am just going to do one more example and then show you something slightly different. So this is going to be example 3. Here I'm going to have f of x equals x squared minus 2x plus 1. What makes this a little bit harder is, and we've come across these before when we were expanding brackets a while ago, we've got a quadratic equation here. Now, because we've got a quadratic equation, we've got a squared term in there, so you just need to be a little bit careful when you are substituting in using this f of x notation. So let's do f of 5. So what have we got to say here? We've got to say that we're going to put our 5 in instead of our x's. It's in more than one place, so there's a 5 there and it's squared. Minus 2 times a 5 plus a 1. 5 squared is 25. Minus 10 plus 1. So we're going to end up with 25 minus 10, which is 15, plus 1 is 16. Now, these aren't any harder than normal functions, except for the fact that I am going to use a negative number this time. So using a negative number, I need to remember when I substitute it in that a negative number, when it's squared, it means it's times by itself. A negative number times a negative number gives you a positive number. Let's pop in all of these negative 3's into our function here and see what we get. So minus 3 squared, that means minus 3 times minus 3, that means it's going to be a positive 9. Minus 2 times minus 3, 2 negative numbers multiplied together again, that's going to give me a plus 6. And then finally on the end there's the plus 1. These are the ones that people get wrong, gentlemen, and that is because they don't remember their rules of negative numbers. If you just pop this into your calculator, remember a calculator, if you put a minus 3 squared into a calculator with no brackets, you'll get minus 9. That is wrong. Minus 3 times minus 3 is 9. Then we've got minus 2 times minus 3, which is your 6, and a plus 1 on the end. Altogether, that gives me 16. Okay, so we have looked at a function that is a quadratic function, and that's probably about as bad as these are likely to get for you in terms of questions. Last thing I want to look at, so if you need to take a note of that, please do. Last thing I want to just take a look at is when you get told that a function is equal to something. So here we go. I've got example 4. So I'm going to go back to one of the ones that I used earlier. So I'm going to use f of x equals 6x minus 12. Now here, I'm going to say that you are told that f of x equals 0. Now, that does not mean that you substitute in x equals 0 into this. That would be something different. That would be f of 0. That's not what this is saying. It's important that you understand that that is not what that is. This is saying f of x equals 0. That's saying your function, this whole function here, is equal to 0. That means then that 6x minus 12 is equal to 0. if 6x minus 12 is equal to 0, you can just solve it like you would a simple equation. Add 12 to both sides, 6x equals 12, divide both sides by 6, x is equal to 2. So this is something different, yeah? This is saying that your whole function is equal to something. It's not substituting in for x. Let's do another one. Let's do g of x, because sometimes functions do get given different names, is 2x plus 3. And let's just say that g of x is equal to minus 7. So we go through our process. So g of x is equal to minus 7. That does not mean g of minus 7. That does not mean that. It means that this function, 2x plus 3, is equal to minus 7. How do we go about solving that? Well, we just solve it like a normal equation. So subtracting 3 from both sides, 2x equals minus 7 minus 3, which is minus 10. Divide both sides by 2, x is equal to minus 5. So some negative number rules there, yeah, minus 7 minus 3 gives us the minus 10, and then minus 10 divided by positive 2 gives you minus 5. I've just thought there is one other thing I would quite like to tell you, and that's going to be our example 5. So are you ready, gents? Pause and copy that down if you need to. Last thing I just need to mention here, and that is if you were going to substitute something other than a number into your equation, into your function rather. So let's go back to f of x equals 2x plus 3. If you were just asked what f of a is going to be, well, all you need to do is substitute in an a instead of an x. So you would just say 2a plus 3. And there's nothing more you can do. Yeah, you don't have a number there, you've just got another letter, so you substitute that in instead of that. If you were asked what f of x squared is going to be, again, all you do is you take the thing in brackets, in this case the x squared, and you place it, you substitute it into your function everywhere where there was an x. So in this case it's going to be 2x squared plus 3. Can't go any further than that, stop there. Last one, what about if you were asked to find f of x plus 2? All you would do here is wherever there was an x in your original function, you replace it with an x plus 2. And be careful, use brackets here, that will help you. So in my original function, I've got an x. So here I'm going to put in an x plus 2. 2 times x plus 2 plus a 3. Well, in this case, I can actually multiply this out. 2x and 4 would be that bracket multiplied out plus a 3. So altogether you'd end up with 2x plus 7. So that's just where you are substituting in something other than an x or other than a number into your function. Okay, that's it for the moment.